All right, so lesson 1.5, we're talking about segment and angle measures. We're starting off with this first postulate. It's the ruler postulate. So every point on a line, okay, can be placed in a one-to-one correspondence with a real number. And I'm going to write this symbol there for a real number. So every point on a line can be placed in a one-to-one correspondence with a real number. So this is just saying that we can't, it's not going to be an irrational number, right? We're not going to have an imaginary number on a ruler. Okay, if you think of the numbers on a ruler, we have 1 and 1/4. That's a real number. Okay, we don't have 0. We don't have negative numbers on a ruler. They're real. Any number, every point on a line can be placed. And so we can't have a negative, we will have negatives. But like, if you think about just a ruler in general, and then we can apply ruler to positive and negative numbers, those are still real. They're just not always whole. All right, so a coordinate, let's look at some definitions, is the number that corresponds to a point. The length of the segment is the distance between 2 points on a line. So we can find the distance using this formula. Okay, so it's the absolute value of A minus B. All right, so let's look at the example 1. Find the length of each segment. So we want to find the length of segment BD. So we're going to use that formula. What is B? -5. And it says minus, right, in our formula, the absolute value, minus, what's the measurement of D? Or the graph of D? 2. Okay. Good. All right, so what is -5 minus 2? So -5 plus, okay, I see. Right, so it's -7, which just equals 7 because it's an absolute value, because it's its distance or its length. We can't have a negative length. You can check it by counting it on there, right? You could start at B and say, well, 1, 2, 3, 4, 5, 6, 7, and count your work. But no, not let's just do that. Because eventually you won't have this number line. You'll have a coordinate graph or some other thing, or you'll just be given the points. And then I say you'll have to make your own line. But then you'll have points that are going diagonal. So then how do you measure those lengths and different things?
Did you just say points going diagonal?
Like the line would go diagonal. Between the points would be diagonal. So then, you know, if you try to make your number line, it may not always work out. So, all right, let's look at the length of AE. So it's going to be the absolute value of A minus E, right? So what's the absolute value, or what's A?
A is -8.
It is -8. It kind of looks off the line there, I'm sorry. So -8 minus, what's E? 3. Okay. What's -8 minus 3? 11.
Oh.
So it's the absolute value of -11, which equals 11. All right, I want you to do EC on your own.
Literally, it makes a plus sign when there's 2 negatives. So just put
I do the same thing. All right, so perfect. This was, you should have gotten a 4 for this. I like that though, Tori. Okay, so let's move up then onto congruent segments. All right, so congruent segments are segments with equal lengths, and it's denoted with this fun symbol over here. Okay, so it's an equal sign with a approximately wave over it. So it's a wavy, not a wavy equal sign, because that means something else, but a wave over the equal sign. All right, between. Point B is between. We talked about between yesterday and the day before, but we're looking at it again. Is between points A and C, and it's notated A, right, with a dash B, dash C. if AB plus BC equals AC. So that's a little bit different than maybe we've seen. Let's use that for an example here. So example 2, find AB and BC if AC equals 75. Okay. So we can clearly see that B is in the middle, right? It said AC is 75. So that means from A all the way over to C is 75. How can we write an algebraic expression to find AB and BC eventually?
Good question.
Okay, so since we know AC is 75, we know that AB plus BC equals 75, right?
Yeah.
Because it's between. That kind of goes back to this idea. So what's AB? 6x minus 1 is AB plus, what's the value of BC? 5x plus 10. So plus, I'm going to put parentheses around it so we can see it, plus 5x plus 10 equals 75. Now, if I look at these, am I distributing anything here in this part of the expression?
Just
Okay, there's no number, like to distribute, I need a number out here, like I need a 2. I don't have that. Okay, so I'm not distributing, so I don't actually need the parentheses. I just put them there so you could see that this part was AB and 5x plus 10 was equal to BC. So I sectioned it off. So let's get rid of them. We've got 6x minus 1 plus 5x plus 10 equals 75. And let's solve. We're going to combine our like terms. What's 6x plus 5x? 11 what? 11x. Okay, then we have negative 1 plus 10. What's that? 9, and it's a positive 9, so it's going to be plus 9 equals 75. Lucas, what do I do next?
You subtract 9 from 75.
Glorious. I subtract 9 from 75. Leaves me with 11x equals 66. Right? We're good with my math there? Tori, what do I do next?
divide
By?
11.
Good. I divide by 11 on both sides. X equals 6. Awesome. Are we done? No, why not, Justice?
Because you're trying to find out the distance between A and C or whatever.
Okay, so I'm trying to find the distance of AB and BC. So I got to plug X into those equations, right? So 6x minus 1 is going to become 6 times 6 minus 1. Right? That's AB. 35. Wonderful. Okay, and so let's do BC. Right? That was 5x plus 10. So now it's going to be 5 times 6 plus 10. 40. Very nice.
Is that supposed to be multiplication 6 times that little dot?
Yes, it is. Sorry, sometimes I use a dot, sometimes I use parentheses. Good question. So then there's a fun question for you. Is B the midpoint? No, why not?
Because it's not in the middle.
It's not in the middle, right? One side has 35, the other has 40. It's not the middle. Is it between?
Yes.
Why is it between?
Because it's between both A and C.
Okay, right? That's a little tougher. Okay, yes. So we can have a point that is between, right? B is between A and C, but that does not make it the midpoint. So there's a lot of lines like that. That's probably one of those things you're like, well, duh, Mrs. Talbert. Like, or, if I have A and B and I had C over here, I could have a J, right? J is between A and C. It's definitely not the midpoint either. Right? We can see that. So we can have points that are between but are not the midpoints. Awesome. All right, let's go down to the protractor postulate. All right, so a protractor postulate says any angle A, so any angle A can be placed in a 1-to-1 again correspondence with a degree measure less than or equal to 180 degrees. So any angle A can be placed in a 1-to-1 correspondence with a degree measure less than or equal to 180 degrees. All this is saying is that you can measure every angle with a protractor. It's why it's the protractor postulate. The other one was saying I can measure any angle line with a ruler. Now I can measure any angle with a protractor. How much practice do you all have with protractors?
Very, very, very little.
Okay. Justice, is that the same for you? Little practice with a protractor?
I've done it quite a bit.
Quite a bit. Okay. Lucas? Quite a bit. Okay. All right. So, how would you describe this first angle here? Oh, what happened? Oh, okay. Acute! It's a cute little angle, right? Acute. Which means, okay, we're going to get into this. It means that its measure, we're going to use the letter M when we talk about angles, always. Okay, so its measure is greater than 0 degrees, but it's also less than, what's the rule? Acute angles are less than how many degrees?
90.
90!
Yeah.
Woohoo!
So it's greater than 0.
Next one's a right angle.
Next one's a right angle.
So less than.
What do we know about the measure of a right angle?
It's 90 degrees.
It equals 90 degrees. Must be equal. No less than symbol there, right? Good. What's the next angle called? Obtuse. All right, what do we know about the measure of it?
It's always greater than 90.
All right, M is greater than 90 degrees. And what else do we know?
Justice?
It's less than 180. Perfect.
Next one, I don't know what it's called, but it's
A line?
Yeah, it's called a straight.
Straight, yeah.
It's a straight angle.
Straight. So it's literally just a line.
Okay, and so what's the measure of that one?
180?
Equals 180. Yeah, good. So protractor postulate says, hey, I can measure any angle with a protractor. Awesome. And then reviewing some angle types there, angle measures. All right, are we good to go on? Perfect. All right, so find the measure of each angle, then classify. See the example picture on page 26. Okay, so you're going to have to open your book to page 26 to see the angle, because this is one, it was way complicated. I was not going to draw it on my paper.
Why didn't you want to draw that? It doesn't look that bad.
Oh, because it had the protractor and everything else. That's why. I was like, I can't remember actually. But yes, it has the protractor on it. And so,
Which page again?
26.
Towards that 100,
That's because all I did was go like that.
Okay. All right, so page 26. What is the measure of angle BAC?
BAC, hold on. What do you mean?
Well, first of all, you could ask yourself, is this an acute angle? Is it a right angle? Like,
Right.
is it right? Remember, right is always 90 degrees.
It's acute.
So BAC. Let me,
That's an acute angle.
BAC, yeah, that's.
yeah, okay, so if we look at BAC,
That's
it's an acute angle.
Oh, I was looking at BAD.
Okay, good, that's all right. So BAC is an acute, so what measurement? Because it comes through right there, a 60 or 120. Which one is it? 60, okay? Because one, we know it's acute, so it has to be less than 90. Two, wherever your line is, like CA is a 0. Is 0 on the inside or the outside of this protractor?
Inside.
Inside. So your angle measure is going to be the one on the inside too. Okay, that should help you. All right, how about angle EAB?
That's an obtuse.
Obtuse. And so how many degrees is that? 120. Because again, EA is, the ray EA is on this side. So 0 is on the outside. So we're looking at the measures on the outside of the angle this time. Perfect. And how about angle BAD?
90. It's a right angle.
It's a right angle. How did you get that it was 90?
Because it's a right angle.
Because right angles have to be 90.
But it doesn't show. It doesn't have a sign. It doesn't have the thing in the corner that shows
So
it's a
you
right
put
angle.
little square in the corner.
Haha, no, we don't get to draw a square in the corner.
But that's how you check if it's a right angle.
Just like we check the distance of a line.
It goes if you.
What is
It's 30 and 120.
30 minus 120? Sorry, I don't need an 30 minus 120
Equals 90.
equals the absolute value of, so we've got negative 90, so 90 degrees.
I'm at 26.
So you are correct that it is a right angle, okay? But we also have to think about why it's a right angle, okay? Because we can subtract those and find the angle measure, just like we found the distance of a segment of a line. Good? All right.
I feel like I'm more confused. I was missing 10 minutes and I'm missing 3 days.
I'm sorry for that. I didn't mean to laugh.
It's because you had to go do a breathing treatment.
It's okay. All right, so then let's look at congruent angles. Congruent angles are angles with equal measures. Hopefully you know congruent, like you've heard it before.
Am I supposed to write down the thingies on example 3?
It's okay.
You should have.
I was busy looking at the screen.
Okay, 60 degrees and acute. So we had 60 degrees, acute. Yeah, 120 degrees, obtuse. And then 90 degrees, right. All right, so congruent angles are angles with equal measures. So if we look at angle X, it's 30 degrees. Angle Y is also 30 degrees. Okay, so they're congruent. Now how we write this is we're going to write it as angle X. Do you remember the sign for congruent?
Nope.
Not the C. Nope. Remember, it was the equal sign with the squiggly. Okay, equals angle Y. If, excuse me, the measure of angle X equals the measure of angle Y. So I'm just restating what the definition says in mathematical symbols, right? Angle X is congruent. So congruent is this word to angle X if their angle measures are equal.
What's the M?
M stands for measure.
That's what M meant.
All right. Then adjacent angles are angles with a common side, but they have no common interior points. So here's the thing. They're going to have a common vertex, and they're going to form a larger angle. So here, angle MNK is adjacent to angle, what'd you say?
KNP.
Yes, K in P.
So they're adjacent because they have the N,
Because they have a common side,
which is the K,
the K, K in is their common side, and they have a common vertex,
which is the N.
which is the N. You got it.
Okay.
Adjacent just means beside each other, right? Like Tori is
Yeah.
adjacent to Justice, right?
Yeah.
They're side by side. That's the same thing. You're good. All right. Angle addition postulate. Then, if K lies, hold on, let's see. Yeah. Okay. So if K lies interior, what's interior mean? Inside. So if K lies interior of angle M in P, then, let's see, keep losing my place. The measure of angle M in K is equal to the measure of angle M in P. So if K lies interior of angle M in P, so let's break that down. Are you done writing actually?
No.
Okay, let me let you finish writing the definition before we break it down.
Because my hand's shaking.
If K lies interior to angle M in P, then the measure of M in K is equal to the measure of M in P.
Okay.
Hold on, I missed a part. I was like, wait a minute, that doesn't make sense when I step back and read it. I'm so sorry. To change it. So if K lies interior to angle M in P, then the measure of angle M in K plus, there we go. I was like, that doesn't make sense. The measure of M in, or K in P equals the measure of angle M in P. So pause writing that so I can make it make sense first, which is why. So this is saying if K lies interior, okay, K is interior to angle M in P. Do you agree with that?
Yes.
Yes. Okay. Then it says if that's the case, then the measure of angle M in K, make me green, come on. It doesn't, okay, M in K plus, right, we're adding that to the angle measure of K in P. So if I add those two angles together, those two adjacent angles together, then I'm going to get the measure of angle M in P. We're going to get the whole angle. Do we agree with that?
Just hold on. I'm waiting for my white out to dry.
Okay. So it's the same thing, like you guys know complementary angles. Two angles that sum to be 90 degrees. Supplementary angles. Two angles that sum to be 180 degrees. That's all this is angle addition postulate is telling us. We can add two angles that are together and we get the size of the bigger angle. Okay. Okay, let's then finish up with example 4 down here. All right, so find the measure of angle 2 and the measure of angle BAD if the measure of angle 1 is 55 degrees. Okay, so angle 1, I'm going to go ahead and label 55 degrees. Okay, so if we look at this, these two angles, what do we know about angle 1 and angle 2?
They look the same.
They're acute.
They look the same. What else do you know? Maybe I'll erase this. There's some important stuff in there.
They're acute.
They are acute, okay?
And they're right beside each other.
They're
They're adjacent.
adjacent. Awesome. So we've got acute, adjacent,
And they have C in the interior.
They have C in the interior. Man, that's good stuff. Okay?
Have 2 lines type angles.
Do you know what those 2 lines mean?
No.
Problematic. Okay, that's what I'm going for.
Oh,
So,
we should have 2 lines on all of those?
no, when they have the same number of lines, it means the angles are
The same.
congruent. Right? So we have congruent angles.
Congruent means the same.
Congruent means the same. So they are congruent as well. So if you ever see like, have you seen a rectangle like this and it'll have like 1 line on those 2 sides?
No.
And then it has 2 lines on these 2 sides?
Yeah.
Okay, it's because this side length and this side length are the same. And this side length is congruent to that side length.
Yeah, I remember that.
Okay. Or you might have a shape like this. And so these 2, a trapezoid. Okay. So, but it's saying like, even though my drawing doesn't look like it, I'm saying this side and this side are the same length.
Maybe that's why they do it, because people's drawings were so bad, they just like, you know what, we're going to have to make it look.
It's true. That's,
People mad.
yeah, agreed. But that's that symbolism, whether they're lines, if you have a line segment, it's always going to be a little tick mark. If it's an angle, it's going to be a curve. Okay. So they both have 2 curves.
Question, why is it 2 and not 1?
I don't know. They could have done 1 on both, but they didn't. Good question. All right. So then the measure of angle 1 is 55 degrees, but we also know that the measure of angle 2 is also 55 degrees because they're congruent. So we know measure of angle 1 is equal to the measure of angle 2. So we could say angle 1 is congruent to angle 2. So this is just math speak, right? For us to get practice in math speak. But ultimate question, how do we find the measure of angle BAD then?
Who add those 2 together?
We add them together. So again, measure of angle 1 plus the measure of angle 2 is going to give me the measure of angle BAD. So we're using some math speak. All right, what's the measure of angle 1? What was it? 55. Good. What's the measure of angle 2?
55.
55. So that's going to give me the measure of angle BAD. So what's 55 plus 55? 110 degrees is the measure of angle BAD. Perfect. All right, now before you go, on the bottom of your paper or on your whiteboard, I want you to do some on your own. We're going to start doing some on your own problems. So these are questions that you have to answer on your own, and I will check them. And then after I check them, I'll have the answers to the homework up. You can check your homework, or you can start working, which you do need at some point. You can start working on your own homework as well.
Or take a nap.
Not take a nap. Good try, but false.
I'm going to take a nap